Welcome to the introduction to electrical engineering. My name is Manali. Let's move towards the main topic. So our today's contents are KCL and KVL, means Kirchhoff's current law and Kirchhoff's voltage law, and then we will see Faraday's law of electromagnetic induction. First we will see Kirchhoff's current law. So the algebraic sum of currents entering and leaving a node is 0, which is known as Kirchhoff's current law, and it is also defined as current entering a node is equal to current leaving the node. For example, if 5 ampere enters a node and 2 ampere current and 1 ampere current leaving the node, then the third outgoing current can be calculated as I is equal to 5 minus 2 minus 1 is equal to 2 ampere, and this KCL is based on conservation of charge. This is the main you can say this is the example for KCL. Here you can see that the middle one, purple one color, this is a node, and here currents I1, I2 and I3 entering the node, and current I4 and I5 leaving the node. So you can write the equation for KCL as I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Next one is Kirchhoff's voltage law. So this is the statement for KVL. The algebraic sum of all voltages around any closed loop is 0, that is summation of V is equal to 0. The sum of voltages rises is equal to sum of voltage drops. For example, for a loop with a 12 volt source and voltage drops of 4 volt and 3 volt, you can write it as 12 minus 4 minus 3 minus V is equal to 0, so that voltage is equal to 5 volts, and this is based on conservation of energy. This is the demonstration for KVL. Here you can see that this is a loop, and you can write the equation for KVL as voltage at AB plus voltage at BC plus voltage at CD plus voltage at DA is equal to 0. Here you can see that these 4 resistors are here, middle one is a loop, and nodes are like A, B, C and D. Next one is difference between KCL and KVL. So this is a difference table. So KCL is applied at a node or junction, and KVL is applied around a closed loop. KCL deals with current and KVL deals with voltage. KCL is based on conservation of charge and KVL is based on conservation of energy. Sum of currents is equal to 0 in case of KCL, and sum of voltages is equal to 0 in case of KVL. Then we will see Faraday's law of electromagnetic induction. So there are 2 laws for Faraday's law. First one is Faraday's first law, and next one is Faraday's second law of electromagnetic induction. First we will see the first law of electromagnetic induction. So statement is like, whenever there is a change in magnetic flux which is linked with the conductor or coil, then at that time EMF is induced in it if the circuit is closed and induced current flows through the circuit. That was the condition for Faraday's first law. Next one is Faraday's second law of electromagnetic induction, and statement for the same is the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked with it. So mathematical expression for second law is E is equal to minus n d phi by dt, where E is equal to induced EMF and its unit is volts, n is equal to number of turns in the coil, and phi is equal to magnetic flux which is measured in Weber. D phi by dt is nothing but rate of change of magnetic flux, and the negative sign represents the Lenz's law, indicating that the induced EMF opposes the changes that produces it. So this is our today's lecture summary. KCL means current entering a node is equal to current leaving a node. KVL means sum of voltages in a closed loop is equal to 0. Faraday's first law is nothing but change in magnetic flux induces EMF, and Faraday's second law states that E is equal to minus n d phi by dt, and greater the rate of flux change, greater the induced EMF. Thank you. Today we will stop here.